And you should come out with x equals 24. And that was what Jacob saw. He just saw 24, and he looked at the board, and he's like, that is my correct answer. But you have to multiply it by 2, because I actually have 2 of these x's, because I want m. So m actually equals x plus x, where m is going to equal 48. 48 was the correct answer. So if you got 48, which everyone did that answered, you were correct. Questions on that? Okay, then we will go through the lesson. Remind me at the end that we should go over homework questions as well in case I forget. All right, Pythagorean theorem. In a right triangle, the square of the hypotenuse is equal to the sum of the squares of the legs. In other words, if I have a right triangle, so I'm just going to circle that, right triangle, then a squared plus b squared equals c squared. So if I have a right triangle, then we can always say leg squared plus leg squared equals hypotenuse squared. Remember, hypotenuse is your longest side. It is the one across from the right angle, but it is also your longest side. The Pythagorean theorem converse, it says if the square of one side of a triangle is equal to the sum of the squares of the other two sides, then the triangle is a right triangle. Hey. So in this case, it's going to be if a squared plus b squared equals c squared, then we have a right triangle. The most important part about this check is you have to recognize which is your hypotenuse. And your hypotenuse is going to be your longer value, because we're going to get to problems where it's just basically what it says down there, where I give you 3 sides and you have to prove whether it's right or it's not. So you have to locate your hypotenuse first and foremost. So if we have a squared plus b squared equals c squared, then we have a right triangle as long as we know which one is our hypotenuse. So we're going to start out. Is the triangle with sides 3, 4, and 5 a right triangle? Let's stop right here and ask ourselves, which is the hypotenuse? 3, 4, or 5? Evan?
5.
It's going to be 5 because it's the biggest side, right? So if it's a right triangle, then this would be my hypotenuse. So to make this a right triangle, it would have to be 3 squared plus 4 squared would have to equal 5 squared. But I'm not sure if that's true. So I'm going to put a little question mark saying, well, I'm putting an equal sign, but it might not be true. Now you just have to do the math. Well, 3 squared is 9. 4 squared is 16. 5 squared is 25. Well, 9 plus 16 is 25. And we have 25 equals 25. So that is good. So it is a right triangle. So we have a right triangle. Well, if I give you one that's a right triangle, you better believe the next one probably isn't a right triangle. Once again, I'm just going to look at 4, 5, and 7. I'm going to locate which is the biggest side. I'm going to call that my potential hypotenuse. So that would be 7. 7 is my potential hypotenuse. And in order for this to be a right triangle, 4 squared plus 5 squared would have to equal 7 squared. Once again, I'm not sure if that's true. We'll do the math. 4 squared is 16. Plus 25, question mark, does that equal 49? And it turns out it does not, because this is 41. 41 does not equal 49, so it's not a right triangle. Is that a hard check? Is it mind-blowing or anything? All it takes is a little bit of study and a little bit of practice. Do not get these ones wrong on the test. All right, it just takes a little bit of practice, a little going through our notes, and knowing how to do it. But the big step is locating your hypotenuse. Otherwise, you can't set up the problem. Because you will never get this right if I was just like 3 squared plus 5 squared equals 4 squared, because it's never going to equal All right, so that is how to tell if something is a right triangle. Our next thing is classifying triangles. We're going to go ahead and classify triangles just by knowing some information about a squared, b squared, and c squared. So the first one is if a squared plus b squared equals c squared, then the triangle is a right triangle. That's what we just said. We just said that. Well, the next one says, what happens if while I'm solving this, it turns out that c squared is actually bigger than a squared plus b squared. What that's telling you is your hypotenuse is too long to be a right triangle because it's bigger than a squared plus b squared. So in order to justify this being too long, you'd have to bend this out. You'd have to bend this out and it would look something like this. So rather than writing like that, you'd have to open it up just a little bit wider. Go. That might have been a little too extreme, but say that's my 11, that's my 7, that's my 8. What kind of triangle is that when it opens past 90 degrees? Amber? Obtuse. So it's going to be an obtuse triangle. Wants to take a guess at what kind of triangle it would be if c squared is too small? Yeah.
Acute?
It's going to be acute. Yeah, that's going to be a cute triangle. It's going to be a nice, adorable, acute triangle. And that's because now it's too small. In order to accommodate the fact that it's too small, instead of being a right angle, we'd have to open less than 90 degrees. Maybe it looks something like this, where we have our 7, our 6, our 8. That is definitely a cute triangle. I'm going to put a note on here that's really important. Always identify your hypotenuse. Always identify your hypotenuse. Always identify your hypotenuse because there's going to be times you're going to put your c squared on the wrong side. You have to ask yourself, where is my hypotenuse in the equation? And how is that inequality sign affecting the hypotenuse? So if I would flip this, this would be a squared plus b squared is bigger than c squared. Don't just look every single time it has going in this direction that it's automatically an acute triangle. Locate where your hypotenuse is and what is that in reference to your sides. It will not always be in this order. In fact, how about we write that down below? So this could be or a squared plus b squared is greater than c squared. In this one, you might see it as a squared plus b squared is less than c squared. Either order works for either one. Okay, let's go ahead and do some practice with it. Okay, the first one said, is the triangle 11, 17, 22 right, acute, or obtuse? First of all, I'm going to say, which is my hypotenuse? You should be thinking 22 would be my potential hypotenuse. So that means 22 squared. Well, I don't know what it has to do, so I'm just going to say it might equal. It might equal. That's where I use my kind of question mark. 11 squared plus 17 squared. Well, 22 squared is 484. Oh, did I really? 484. 11 is 121 plus 289. Still not sure if that equals or not. So now we're going to have a 484. Don't forget this is my hypotenuse. That's my hypotenuse side. And my other side is 410. 484 is greater than 410. If my hypotenuse is greater than the side squared, what kind of triangle do I have? Akshay? Obtuse. It's going to be an obtuse triangle. It's an obtuse triangle. But make sure you're tracking where your hypotenuse is all along. In fact, I circle it a lot of times just like this, so I don't accidentally go 484 is greater than 410. It's acute because 410 is less than 484. Make sure you know where your hypotenuse is. All right, is the triangle with sides 5, 5 square root of 3, and 10 a right, acute, or obtuse triangle? What is my hypotenuse in this one? What is my hypotenuse in this one? If I have 5, 5 square root of 3, or 10. Hannah? 10? Are you sure 5 square root of 3 isn't bigger than 10?
Yes.
How did you check that? You just plug in a calculator, guys. This isn't, you have to memorize that 5 square root of 3 is smaller than 10. Just plug in your calculator, double check. So 10 is our biggest side, so it will be our hypotenuse. Yeah.
Wait, how do you find that? Like, because I did the 5 here, like, and then this, and it said that it equaled that.
I'm going to go through your modes because you should have a button that will round it. I'll have to come over there later, though, because I have not used your calculator.
Oh.
All right, so that is my hypotenuse. So we're going to say, well, maybe 10 squared, maybe it equals 5 squared plus 5 square root of 3 squared. Well, that's going to be 100 on the left-hand side. Still not sure if it's equal to, greater than, or less than, so I'll put a question mark. Well, that's 25 plus 5 squared is 25 times square root of 3 squared is 3. Well, that's 100. Well, that's going to be 3 times 25 is 75 plus 25 is 100. They are equal, so it is a right triangle. Our last one just says specify all values of x that make the statement true. That make the statement true. If you're not sure what to do in any math problem, just try something. Just try something. So it says measure of angle A is a right angle. So if I'm looking for A being the right angle, that'd make the other side my hypotenuse. So they're asking what value of the hypotenuse would make this true. Do you think it's important to locate which you're looking for? Hypotenuse or side lengths? Could I have said angle C is my hypotenuse, or angle C is the one I'm looking for? Yeah, in which case 5 would have been your hypotenuse. It wouldn't work with 12, but make sure you're well aware of which is your hypotenuse and what you're looking for. All right, so in this case, in order for angle A to be a right angle, the hypotenuse would have to equal the sides squared. So that means 5 squared plus 12 squared would have to equal x squared, since this is my hypotenuse. Well, 5 squared is 25. 12 squared is 144. That should equal x squared. Then we're going to have, well, that's going to be 169 equals x squared. I would take the square root of both sides to get rid of that square, and we're going to come out to x has to equal 13. In order for this to be true, x has to equal 13. Well, then it says, how do I know if angle A is acute angle? To know if it's an acute angle, if it's nice and pretty. Mr. Bansky. Remember, in order for it to be acute, our hypotenuse squared has to be less than the sides squared. So we're just going to set it up just like that. In order for it to be acute, our hypotenuse squared, which would be x squared, has to be less than our side squared, which would be 5 squared plus 12 squared. Well, we did all that math already up there. All that math is already up there. Where 5 squared plus 12 squared, we said x squared is less than 169. We would take the square root, and we'd have x has to be less than 13. So x must be less than 13 for it to be acute. X has to be 13 to be a right. Let's jump right to the answer on this one. What does x have to be for it to be an obtuse angle? Yeah, it has to be greater than 13. Are there other requirements on this? We're not going to go down that path right now, but are there other requirements? Could x be 100? Could x be 100? So if x was 100, would 5 and 12 still make a triangle? If x was 100, let's do a little picture. So if x is 100, say that's my 100, and we have our two sides are 5 and 12. Is that going to make a triangle? Everyone seems a little bit confused. Is that going to make a triangle? No. Are there other requirements that we'd have to consider if I asked a more specific question? Yes, but we're not going to worry about that. But for the final, you're going to have to worry about that because we did go through what makes a triangle or not. Right? It has to be, if I do 12 plus 5, it has to be less than 12 plus 5. So there are other requirements, but for right now, we're just going to say x has to if x equals 13, it's a right. If x is less than 13, it's an acute, and if x is greater than 13, it is going to be obtuse. Any questions on that? All right, what questions do we have from the homework? Yeah.
37.
All right, 37. Do you have a specific question? This is a big, long problem. All right. 37 is a great question because it really puts a bunch of algebra knowledge and geometry knowledge put together. So you are given this triangle, and you are supposed to find h. But none of the right angles you could come up with, or right triangles, could actually solve for h because all of them had variables in it. So you had to break it down into two triangles. One that's length x, and one length that's 21 minus x. That is my two right triangles you had to create. Well, if I tried solving the one with x, so I just pulled out this triangle, then we're going to have hypotenuse squared, which is 20 squared, equals h squared plus x squared. And I'm actually going to solve for h squared. All right, because that's at the end of the day, I want to know what h equals, so I just solve for h squared. Then I pulled out the other triangle. I said, well, that one had a base of 21 minus x, hypotenuse of 13, and it also had the h in it. And so I said, well, hypotenuse 13 squared would equal h squared plus, well, that's 21 minus x squared. That is a binomial times a binomial. Once again, I worked it all the way down until I solved for h squared. Well, what I did here is I just used substitution. I said, well, h squared equals negative x squared plus 400. Well, h squared also equals negative x squared plus 42x minus 272. So I just took this value here, and I plugged it in for that h squared. Well, that got me this formula down here where I have negative x squared plus 400 equals negative x squared plus 42x minus 272. Well, the big goal here was I got rid of the h's. I got rid of the h's so I can actually solve for a variable. And my negative x squared is going to cancel out because you would add x squared to both sides. We keep solving down. We come up with x equals 16. X equals 16 was not my answer. I'm still looking for h. But now what I can do is, since x equals 16, I can just throw that guy in for that x, which is what I did down here, where we have a 16h and 20. Now I just use my right triangle, a squared plus b squared equals c squared to solve for my h. Okay? Other questions from the homework? That was probably the toughest one. Can this be on the test? Yeah, I think people get this tendency, like if it's a hard problem on a homework, it's not going to be on the test. Anything that comes from the homework that I showed you can be on a test. Me personally, I'd like this problem because, you know, there's lots of points you can get from it. You can just do what you can do, solve stuff. Even if you make a mistake, you get most of the points. All right, one last time. Any questions from the homework? Okay, if you look